Hello, I will start with 10.4 to 10.5 sum and difference formulas, along with the half angle and double angle formulas, and many others. To start, I will show you the sum and difference formulas. As you can see, the sum formulas are to be used when you have degrees and radians, which you know the exact dimensions of the triangles in a unit circle, and same thing for the difference formulas, except they're a difference. Now, to move on, I have an example problem right here. It's using the sum formula of cosine, which we saw was cosine of a plus b, cosine of a times cosine of b, minus the sine of a sine of b. This example problem, cosine of pi over 4 plus pi over 3, you're going to want to draw the unit circles, or the triangles on the unit circles, so because you know the dimensions of pi over 4 and pi over 3. So you'll know that pi over 3, 1, root 2, and root 2, while this is pi over 4, this is pi over 3. This will be 1, root 3 over 2, and 1 half. Moving on, you will solve the equation by plugging in the variables. So the cosine of a, which is just root 2 over 2 times the cosine of b, which is just 1 half, minus sine of a times the sine of b, which will just equal root 2 minus root 6 over 4. Moving on to the double and half angle formulas, you see that the double angle formulas are derived from the sum formulas, and the half angle formulas are very similar. As you can see, if we go back up to the sum formulas, it will just be sine of a, cosine of a, sine of a, cosine of a. So it would just be 2 cosine of a, cosine of a. So they're derived from the formulas we used last. An example problem how to use is using the tangent half angle formula, which we have over here the triangle that we're going to use, which is 6, 8, and of course, since this is a 3, 4, 5 triangle, we know this is going to be 10. So we just put a 10 there, and we know that everything else, we just plug it into the formula, which in this case is sine of the angle over 1 plus cosine of the angle. So you just plug it in, and you get the answer to be equal to 1/3. Next, I will cover the power reduction formulas, which, as you can see, are used when you're asked to take the, say, sine squared of something, or cosine squared or tangent squared. Normally you wouldn't be able to do that, but using these formulas you can. The practice problem I have is sine squared of pi over 6. Relatively simple. First step, of course, we make our unit circle and fill in our known dimensions for the x and y, the hypotenuse, which is always 1. Then we plug it into the formula, which for sine is 1 minus cosine of 2a, 1 minus cosine of 2 times pi over 6 all over 2. Of course, since it's 2 times the actual angle, we'll put it to pi over 3, simplifies to pi over 3, so we'll make another unit circle over here, and finally the answer comes out to 2 minus root 3 over 2. That should be all over 2, so you get 2 minus root 3 over 4. Alright, I'm going to cover next the sum to product and product to sum formulas, as you can see here. These are an addition to the sum and product, the sum and difference formulas, because it makes extensive use of them. These are used when you have something like, say, the cosine of an angle minus the sine of an angle, and so on and so forth, which you can't actually just use the sum or difference formula for, because sine doesn't just distribute as shown by the actual sum formula. You can't just take the sine of A plus the sine of B and get the same answer. That's not actually correct. The sum and product formulas, as seen here, will make use of the actual sum and difference formulas, though. So it's building on top of the earlier learned formulas. The example problem I have here is the sine of 7 pi over 4 minus the sine of 2 pi. Let's move that a little. 2 pi over 3. Of course, first step, you're always going to want to draw your unit circles. In this case, 7 pi over 4 and 2 pi over 3. Plug it into the equation, which in this case is 2 sine of a plus b over 2 and cosine of a minus b over 2. So from moving further down to show my work, you see I just use the sum and difference formulas, and then multiply them together and by 2, and I get 2 minus root 3 over 2.